So very good morning to one and all. Today we are going to discuss about another important topic, that is sheet metal characteristics. So before moving on to the topic, let me ask you a question. What do you mean by sheet metal forming? Or sometimes you may have heard that press working or press forming. And what does it mean? Now you have learned about different type of manufacturing process like casting, forging, rolling, like the conventional casting process. And what is the advantage of press working compared with those processes? If I have a direct simple answer, that would be compared to those products made by casting and by forging, the sheet metal parts offer the advantages of lightweight and versatile shape. So that is the prime reason, one of the prime reason we developed this press working forming operations. So let me directly enter into the topic. Yeah, it is this process is commonly referred to as press working or press forming operations. Press working or press forming. So actually this process is used commonly in industry to describe general sheet forming operations. So this is a name, that is a press working or press forming is commonly, so it's used commonly in industry to describe general sheet forming operations. Now as I mentioned you earlier, the products made by the casting or forging, usually they are heavier. Okay, and if you want to use a lightweight or for making lightweight and versatile products like appliances, automotive parts, cans, household utensils, etc., we prefer to use sheet metal. So that is the reason, one of the reason why we are moving on to the sheet metal forming operations. So for making lightweight and versatile products like appliances, automotive bodies, cans, household utensils, etc. So it is preferable. So it's considered to be the sheet metal. The sheet metal is considered to be a plate with a thickness between 0.4 mm and 6 mm. ഈ പറഞ്ഞിരിക്കുന്ന റേഞ്ച് ഓഫ് വാല്യൂസിന് ബിറ്റ്വീൻ വരുന്ന പ്ലേറ്റിനെയാണ് ഷീറ്റ് മെറ്റൽ എന്ന് പറയുന്നത്. So the sheet metal is generally considered to be a plate with thickness between 0.4 mm and 6 mm. Now the low carbon steel is the most commonly used sheet metal. Why it is used as the sheet metal? Because it has a very low cost with good strength and for mobility. Because of the low cost and generally good strength and for mobility characteristics, low carbon steel is the most commonly used sheet metal. Now let's look into some of the sheet metal characteristics, which means certain characteristics of sheet metal which are having important effects on the sheet metal forming, which we are going to explain now. Certain what are those characteristics which are influencing or which are having important effects on the sheet metal forming process? First one would be the elongation. So you know that when you are doing this press working or sheet metal forming operation, the sheet metal is usually being stretched using sheet forming. So since the sheet metal is usually being stretched during sheet forming process, high uniform elongation is desirable for good formability. If you want to form the material I would suggest high uniform deformation is desirable. And another point you should keep in mind is is a high value of strain hardening exponent and strain rate sensitivity index are desirable. What do you mean by strain rate sensitivity index? So it's actually a measure of the change in dynamic stiffness with variations in strain rate. That is called a strain sensitivity index. Measure of the change in dynamic stiffness with variations in strain rate. How its dynamic stiffness changes. So it is denoted by the strain rate sensitivity index. So the material should have high value of strain rate sensitivity index. And again, the strain hardening exponent must be high. What does it mean? It's a materials constant used for stress strain calculations. You know that. And another point you should keep in mind is along with elongation, you know that necking also occurs. Okay, but diffused necking is desirable in sheet forming operations. And the second characteristic of sheet metal which is having effect on the sheet metal forming operation is the yield point of elongation. You know well that I told you already that the low carbon steel is the most commonly used sheet material. Why? Because of certain characteristics. So this low carbon steel that exhibited behavior called yield point elongation. Usually, um, once the material yields, the sheet stretches more in certain regions, while in other regions the sheet has not at all yielded. And this causes or it results in Luder's bands. Luder's bands or the structure strain marks. Okay, because of this behavior, it results in Luder's bands, or it is also known as structure strain marks on the sheet. And you can avoid this by reducing the thickness of the sheet from 0.5 to 1.5 percentage by cold rolling. So that is another characteristics which can affect on the sheet metal forming operation. That is the yield point of elongation. And another point would be anisotropy, which means it's an important factor that influences the sheet metal forming is anisotropy or directionality. Another name we can impose on it is the directionality. Usually the material exhibits different behaviors in different planar directions. That is called anisotropy. You know that definition, isn't it? Usually this characteristic is acquired during thermomechanical processing of the sheet. There are two types. One is crystallography anisotropy and mechanical fibering. Crystallography anisotropy means preferred orientation of the grains. That is called crystallographic anisotropy. And mechanical fibering means the alignment of impurities or inclusions and voids toward the thickness of the sheet. So you can reduce this effect because this is not good at all. So you can reduce the effect of anisotropy. So if a material possesses the same properties in all directions, that would be better. Okay, so anisotropy can be reduced or eliminated by annealing operation. It's a heat treatment. And another factor which influences the sheet metal forming process is the grain size. The grain size affects mechanical properties and influences the surface appearance. The grain size. Okay, and the grain size of sheet metal is important due to two reasons. Because one reason would be the grain size affects the mechanical properties and influences the surface appearance. You should remember these 2 points. For example, in a coarse grained sheet, the surface appears very rough. In a fine grained sheet, the material would be very stronger. You know all these theories. Okay, so the grain size has an influence. And another important factor which influences is the spring back. What is meant by spring back? It is caused by the elastic recovery of the plastically deformed sheet after removing the applied loads. Okay, so that these are the sheet metal characteristics which can influence the sheet forming operation. So we learned about the elongation, yield point of elongation, then anisotropy, grain size, and spring back. Now let's move on to the what does it mean by shearing. So this is actually the basic operation of sheet metal forming. So for example, the basic operation of cutting sheet metal to the required dimensions is called the shearing. So shearing is a basic operation of cutting sheet metal to the required dimensions and shape. So the during this operation, the sheet subjected to shear stresses. So the sheet subjected to shear stresses developed between a die and a punch. If you look at the schematic diagram shown in this slide, you can see a punch here. You can see a sheet. You can see two dies. Which means this sheet is subjected to shear stresses developed between this punch and the two dies. Okay. So during the shearing process, if you look at the diagram, you can see initially the cracks are formed on the top and bottom edges of the workpiece. So those points are marked as point number 1, 2, 3 and 4. So as this shearing proceeds, the point 1 and 2 move towards each other, which means as the shearing proceeds, the point number 1 and point number 2 move towards each other and it meets. So does the point number 3 and 4 similarly. So this leads to the separation of materials and the creation of hole in the workpiece. Okay, now a typical application of the shearing process is to cut large sheets into small sections for subsequent press working operations. That is a typical application of a shearing process. Okay, now let's look into, so based on the shearing process we discussed now, there are several operations can be performed on sheet metals. Let's see what are they. First one would be the blanking. So which means the process of cutting sheet metal along a closed outline in a single step. It's called the blanking. Here in this, so what is demonstrated in the schematic diagram is a blanking. So here the part which is cut out from the sheet is called the blank, and it is the desired product. You need this as the product, and the remaining portion usually this is discarded as the strip. Remaining strip is discarded as the scrap. Another important operation is called the punching. It is similar to blanking, except that the part cut and separated is discarded, which means you see this would be usually discarded and this would be taken. That is the only difference between blanking and punching. Another important operation is called the slotting. The slotting is a term used to all the punching operation for cutting rectangular holes. So punching operation for cutting rectangular holes is called the slotting. Another important operation is called the perforating, which means the slotting is shown in this. You can see it here. Punching operation for cutting rectangular holes. You can see that. Yeah. Another one would be the perforating, cutting a number of holes in a sheet metal for decorative purpose or for the passage of light or air. This is called a perforated sheet. Another important operation is called the notching. Pieces of metal of various shapes are removed from the edges of the sheets. So this is called the notching. You can see it here. You can look at these points. Okay. And semi-notching. Semi-notching means removes a portion of the metal or a blank from the interior of the sheet to create a part of blank outline. So this is called a semi-notching. Okay. Now another important operation is called the fine blanking. The fine blanking is another shearing operation by which the holes with very smooth and square edges are produced in a sheet metal. So holes with very smooth and square edges are produced in a sheet metal using this fine blanking operation. So it is actually limited to sheets of having very small thickness. Another one would be the flanging, bending edges of sheets at 90 degrees. Bending edges of the sheet at 90 degrees. You can see that sheet is bended to this like this 90 degree. It's called the flanging. Usually this operation is done prior to the joining of two metal parts or to increase the stiffness value. That's the load by deflection value. If you want to increase the deflection value with respect to load, this operation would be done. Okay, plunging. And another important operation is called the hemming, which means folding over the edge of a piece of a sheet metal and then pressing it to make it flat. Okay, so that is shown in over here. Folding over the edge of a piece of a sheet metal and then pressing it to make it flat. This is called the hemming. Actually, usually this is done to stiffen the edges of the sheet. And another important operation is called the seaming. To join two sheets, you can see, without using any fasteners or welding or bolts, anything. To join two sheets without use of fasteners or welding. So one or both sheets are flanged before seaming and the joint is made. You can see that. This is called the seaming. So these are the different operations. One is blanking, punching, slotting, perforating, notching, semi-notching, fine blanking, flanging, hemming and seaming. Thank you.